mathematicians, it's Justin again. Ren and Mia have been selling lemonade for $3 a cup, and they've been doing a great job. They sold 38 cups on Thursday, 45 on Friday, and 127 on Saturday. But they aren't sure how much money they've earned. Besides counting the money, which would take a while, how else could we figure out the total? Well, since each cup costs $3, we could use repeated addition. For Thursday, we could add 3 a total of 38 times, or 38 3 times. Repeated addition works, but it can be a lot to keep track of. Is there another way to find the total? With multiplication, yeah. But these numbers are larger than the multiplication facts we usually practice. How can we make them easier to work with? By the end of today's lesson, you'll be able to solve multi-digit multiplication problems using several strategies. Have your guide to notes ready? And let's stir up some new ways to multiply. Knowing your multiplication facts will make it easier to multiply larger numbers. Here's a quick warm-up. 6 times 7 equals 42. What do you think 6 times 70 equals? Notice that 70 is 10 times more than 7. So what's 10 times more than 42? 420. What about 9 times 20 and 5 times 800? How can knowing your multiplication facts help you figure these out? Pause here to solve in your guided notes. 9 times 2 equals 18, so 9 times 20 equals 180. And 5 times 8 equals 40, so 5 times 80 equals 400, and 5 times 800 equals 4,000. Since 800 is 100 times greater than 8, our answer also needs to be 100 times greater than 40. Notice how we used multiplication facts and place value patterns to find each product. Keep that in mind as we try this first strategy. Let's start with the area model strategy. You might have learned how to find the area of a rectangle by multiplying the length by the width. We're going to use that same idea to help us multiply larger numbers. For example, a rectangle could be 3 units wide and 38 units long. We could solve 3 times 38 to find the area, but the numbers are still too big. How can we break apart 38? The area model strategy breaks numbers into expanded form to multiply step by step. By multiplying the tens and the ones separately, the numbers become easier to work with. So we can break 38 into 30 plus 8. We label our area model with one section for the tens and another for the ones. We're multiplying by 3, so that goes on the left side. Now, instead of thinking about this as one rectangle with an area of 3 times 38, we could think about it as 2. One with an area of 3 times 30 and another with an area of 3 times 8. First, we solve 3 times 30, which equals 90. Next, we solve 3 times 8, which equals 24. Since we expanded 38 into 30 plus 8, we need to add 90 and 24 to find the total product, 114. Try using the area model strategy to solve 3 times 45 in your guided notes. Pause here to expand 45, label the sections, and solve. "45 expands to 40 plus 5, so our rectangle will have 2 sections, one for tens and one for ones. We're still multiplying by 3, so we have 3 times 40 and 3 times 5. 3 times 40 equals 120, and 3 times 5 equals 15. What's the final step? Add them together. 120 plus 15 equals 135, so 3 times 45 equals 135. We just used an area model with 2-digit factors. But what about a 3-digit factor, like 127? Think about how the rectangle will need to change and how we can expand 127. Pause here to solve in your guided notes. (127) is 100 plus 20 plus 7. So our area model will have 3 sections. One for hundreds, one for tens, and one for ones. We're still multiplying by 3, so 3 times 100 equals 300, 3 times 20 equals 60, and 3 times 7 equals 21. Add them together, and the product is 381. The area model strategy works for numbers of any size. Just add another section for each place value as the numbers get bigger. Ren and Mia have earned $630 so far. And they're running short on supplies. Let's check out another multiplication strategy to help them restock. Okay, Ren and Mia have ordered 7 crates of lemons, each weighing 314 pounds. How many pounds is that in total? We could use an area model, but what if we followed the same steps without drawing the boxes? That's where the partial product strategy comes in. The partial product strategy works a lot like the area model. They both start by expanding the number. 314 is 300 plus 10 plus 4. Instead of drawing a rectangle, we just multiply each part by 7. 7 times 300, 7 times 10, and 7 times 4. 7 times 3 equals 21, so 7 times 300 equals 2,100. 7 times 10 equals 70, and 7 times 4 equals 28. Just like the area model, we add these partial products together. 2,100 plus 70 plus 28 equals 2,198 pounds. Up next, straws. Ren and Mia ordered 4 boxes, each with 3,406 straws. Pause here to use the partial product strategy to solve. Start by expanding 3,406 into 3,000 plus 400 plus 6. Since anything times 0 is 0, we don't need to include that in our expanded form or partial products equations. 4 times 3,000 equals 12,000. 4 times 400 equals 1,600. And 4 times 6 equals 24. Add the partial products. 12,000 plus 1,600 plus 24 equals 13,624 straws. All right, I've got one last strategy for you. The multiplication algorithm. Notice how it compares to the partial product strategy as we solve 4 times 3,406 again. We'll line up the numbers by place value, like the addition and subtraction algorithms, and we'll start in the ones place. 4 times 6 equals 24. Since we can only record 1 digit in each place, we record the 4 ones in the ones place and regroup the 2 tens, just like how we regroup with the addition algorithm. Next, we multiply 4 times 0 tens, which equals 0, but what about the regroup 2? With the partial product strategy, we multiply each expanded part and then add the partial products together. But the multiplication algorithm combines all of those steps at once. So after multiplying 4 times 0 tens, we add the 2 tens from 6 times 4's partial product to complete the tens column. Since that's a 1-digit answer, we record the 2 in the tens place with no regrouping needed. Then we do 4 times 4 hundreds, which equals 16 hundreds. We record the 6 in the hundreds place and regroup the 1 thousands. Pause here and try the last step on your own. Four times the 3 in the thousands place equals 12 thousands, plus the regrouped 1 from 4 times 4's partial product equals 13. That's the same total, 13,624. Multiplying larger numbers takes practice. Each strategy can be used with numbers of any size. It's up to you to explore and decide which strategy works best for you. So, what have we learned today, besides the fact that Ren and Mia are lemonade stand legends? Well, now you know that the area model, partial products, and the multiplication algorithm are all strategies based on place value. They help break numbers apart to make multiplying larger numbers easier. Be sure to complete the practice questions and extension activities that go with this lesson to practice multiplying multi-digit numbers. And remember, mathematicians, in math, as in life, every effort adds to your success. I'll see you next time.